Yes, this time, following on from last time, I will tell you in detail how this function called FileChangeDetector was implemented. Yes, let me explain in a little more detail what classes we used and what logic we used. First of all, there are two classes. Well, there is a class called FileChangeDetector and a class called FileManager. Oh, when you say manager, it looks more like a big class now. So he actually told me that there was a file database in it, that I had implemented a file database earlier. It is a data structure that contains information related to all files. Anyway, what is this file manager? It is a function that manages the file change detector as a whole by using DB and file change detector. You can think about it, and some entity that actually detects file changes would be this class called FileChangeDetector. So what should I change the file? What to create a detector and make it perform its actual function? Let's say that the file manager is a static function of the class that calls initializes and functions a lot. Then, if I pass the folder path I want to detect and continue to monitor as an argument, a file change detector object corresponding to it will be created, and a file DB corresponding to it will be created. Now let me go ahead, and when I want to monitor any project folder now, is this every number of my project folders? I told you that a new thread would be created and that it would detect these changes. Now the way it works is to create a file change detector for each of these folders and then create a file div and use threads to actually track any of these changes. So what I'm trying to detect now, for each folder, an object called FileChangeDetector and FileDiv is created. You just need to know that first, and then I will register a specific function as an event, as an intermediary, or gatekeeper. In my case, I put a specific function in the file manager and act as a middle manager. What do you mean, sleep? There are a lot of things going on with the files. There may be files that we can see with our eyes, but logs that are used internally or something? If you implement a Windows-specific function, or actually implement this function and execute it, there will be many types of files entering the event. Changes detected. Maybe we don't want to catch them all. For that, any function called this file manager, or any class. Almost halfway through, I set up a certain media event function, and 10 events occurred, but were there 5 files or folders that I really wanted to track and notice? In the end, only for these 5 is that I set up some of these functions in the middle for filtering that I'm going to broadcast to the event receivers now. Now, let's assume that we have completed the preparation process and executed a function that tells us to start monitoring now. Then that path madam creates new cases. Next, let's realize the logic of starting monitoring, and let's talk about which functions were specifically used based on Windows. First of all, get the handle value for the folder through the function called creFile. Next, I want to use overlap IU and do asynchronous IU now. Because when I have a file change, if the game engine is like this, it just has to continue running Willow, regardless of the file change, and execute its own logic. And apart from this, asynchronism. There is a thread, so it has to catch changes like this in real time, and then hand it over to it, so that the event is processed only at that time. So now, as you can see here, we're going to use asynchronous arguments. And one of the many ways we use that asynchronous arguments is we're going to use oblops arguments. So now not only oblact.io, but now you're going to set some events there. Create an event object. For those of you who have no knowledge or no concept about this, you will understand if you take a look at the contents of asynchronous I/O, especially oblact.io in Windows system programming. Okay, so now I'm going to use oblact.io, and let's assume that I created an oblact.io specific event venue for this. Okay, then this is the main. Now, I said earlier that when you create a new project, no. When you create a folder, a newsreader is created to monitor that folder. So it would be good if he continued to come now. This new thread also makes the waypool single object suck the function for the event replacement of oblock.io that I created here. Then we will continue to play in the blocking state until it becomes signaled. Now, using this event object, we're going to realize this function, how to change the lead directory. Well, this function is now a function that specifically catches what file was changed when a file change occurs, what all the changes are, and so on. This is a decisive function, and when an event occurs, this function creates this event object in time. And then this thread, which has been waiting for this event object to be signaled, is finally coming out of the blocking state here and executing some intermediate callback that it registered in the first place. Now, if you're going through the filtering I mentioned earlier, what filtering do you go through? Well, I'm using the file database now. Currently, for instance, let's consider the scenario where I claim to have lost my file. But now, as I examine it, I wonder, what is the file's name? For example, what is it? However, it turns out that this is not the specific file I am looking for right now. It's merely part of Windows itself. Let's assume it's a file that I don't want to deal with. Now, I told you earlier about the file database, and this file database manages these tree structures of this file system under a particular project. Then, here I am. This implies that only the files of the object you wish to observe will be collected in this manner. I received a notification that the file has disappeared and I wish to filter it. What type of extension does the file have? But when I searched for it, nothing was found. Oh, that implies Jackson. This individual is not someone I want to oversee. He decides that he's not of interest to me for exploration, so he just filters here and doesn't take any action. Now, conversely, the file has been deleted. But it's a file with a specific extension, for instance. When I looked, it's in this location. What kind of individual is missing now? Is he the one I want to observe? However, if the object you want to observe disappears, it is then judged that the game engine should additionally handle it. So he doesn't pass through this filter. I'm going to go to the event receivers, and I'm going to go around the guys who want to detect that event, and I'm going to do this broadcast, and I'm going to execute the functions that I want. So what's here? Now, you can execute the logic in a place like this, which manages all the assets that are used in the game engine, or delete this information from the asset database. Yes, it's a bit difficult, but I hope you follow it well. Let's summarize it once again. Now, I want to create a new case for each project, and then separately, I want to perform the logic I want to detect. So I'm going to use asynchronous IU, and I'm going to use oblak IU. To do this, a new event object will be created, and the thread will wait until the event liquid becomes a signal state. At this time, if a change occurs through this function, this new thread and the event object it is observing will change to the signal state, and then this thread will leave this block key state, go through this filtering function once, and then here. Even if the filtering passes now, that means it's an object I want to meaningfully observe. Now, if you take an event broadcast and deliver information to event recipients, each event recipient is actually a function. I think you can understand that these functions proceed on the principle that they perform some logic that suits those changes. Yes, that's it now. I've talked a little bit more about the implementation section on how it was implemented specifically.